Now, I know I've been harping on this a lot, but closures are important. I want to use this topic to point out two features of closures that make them important. Now, these aren't the only features of closures, but two that I want to make sure you understand. The first feature is that closures can help us efficiently use memory or CPU intensive tasks. Now, let me give an example of that. So here's our code that we were using before. And let's say that as a part of this code, we have a process that retrieves data from a database or from an API on some site. Okay, and what we get back from that is we get this huge array. Now I'm going to represent this huge array just with a small array, but think of it as a huge array. This is the data that comes back from the site API, okay, using some sort of asynchronous command. We'll get into asynchronous stuff later, but we have to deal with it asynchronously because it takes a long time for it to come back. But when it finally does come back, we get this array of numbers. All right, and then we are changing this to an index, and basically what we're doing is we're grabbing from the huge array the number that we're going to choose. Okay. Now let me emphasize again that in retrieving this data, it takes a while for it to go out to the database or to the site and get it and bring it back. So we have to deal with it asynchronously. Now think about if each time we wanted to multiply numbers together, we had to do this intensive task. We had to go out and get that data. Each time we did that, it would take the seconds or whatever it is, even if it's a minor number of seconds, even milliseconds, those can add up each time we go out and do that. So it can be intensive. Well, if our get function goes out and gets it once, and then we have it stored in this variable, and then through closure, we're able to continue to access it using the multiply by 5 display and the multiply by 10 display. So that each time we want to multiply by 5, we don't have to go out and get this data. Each time we call this function, it's just referencing what we already have stored in memory. It's already done the process to get it. All right. So that's how it can help us efficiently use CPU intensive or time intensive or memory intensive tasks. By using closure, we can make that continually available for us. All right. Now the second feature I want to talk about, we call encapsulation. Now, in order to understand what encapsulation is, let me just expand on this idea we've got where we have this huge array. Let's say that this is something, this array is something that we don't want to be changed willy-nilly in any part of the program. There's only one place we want to be able to change it, and no place else in the program should that be allowed to happen. Well, we can set up a function, something like this, where we pass in a new number, and then that new number is added to the array. And that's the only way it can be updated. Okay, so we just do a push here with new num. So we don't want people to be able to access this array and be able to add numbers to it. In fact, perhaps every time somebody adds a number to it, we want to check it somehow to make sure it meets some criteria. So we could have an if statement here. If new num is greater than 100, maybe that's all we're accepting or something like that, then we'll go ahead and push it on. And so we control the adding of new numbers to that array using this function. So then the only way people can manipulate the array is with this function. They have to go through this. Now, right now we're returning two functions, which obviously is not allowed. A way we can do that, if we have two functions we want to return from something like this, is we can return an object. So if we just change this function to update array like that, and we change this one to create function like that, we could then return an object, and we'd have update array and create fun. They would both be a part of that object, so that when we call this function, the return is an object. So get function, what we get back is an object. And then we can use that object. We can do obj.updateArray to call this function, or obj.createFun to call this function. So anyway, that's how we would do that instead of doing two return functions. But the point I want to get at is now we've created a function that this is the only way we can change this array. So we've enclosed this array inside a function. We've encapsulated it. So this is encapsulation. It protects it. Only one way to change it, and we can check as that is changed. And really, these other functions are encapsulated as well. They're not available outside of this function. The only way we use them is with this here. This has access to them, but nothing else has access to them. So these are encapsulated. So that's the idea of encapsulation. Both of these features are important features when it comes to closure. All right, let's move on to the next topic.